Good morning. Today's topic is Nernst equation. So, according to Nernst, for an electrode reaction, consider a reaction Mn plus N electron gives M. Okay, consider this reaction. We are calculating the electrode potential of this reaction at any concentration with respect to hydrogen electrode. So, how can we write the electrode potential? According to Nernst, the electrode potential can be written like this. This will be equal to the electrode potential of this reaction is equal to the standard electrode potential, okay, minus RT by NF. R is gas constant, T temperature, and N number of electrons take part in the reaction. F is Faraday's constant, Ln M by Mn plus. So, the concentration of M in solid state is taken as unity. So, the equation becomes like this. Standard electrode potential which is known, okay, minus RT by NF Ln, this is unity, so 1 by concentration of Mn plus, okay, where this is standard electrode potential which is known, okay, then R gas constant which is 8.314 joule Kelvin inverse mole inverse, okay. Now, what about F? F is Faraday's constant 96487 mole inverse, okay, and T temperature in Kelvin, and concentration of the species Mn plus is the concentration of the species in the solution. So, this is the equation according to Nernst. Now, let us take an example, Daniel cell. Example, Daniel cell. Okay. The cell will be okay, anode zinc and cathode copper. Okay, this will be the cell. Okay, now for cathode, how can we write? For cathode, how can we write the Nernst equation? So, okay, it's equal to, the electrode potential will be equal to the standard potential, okay, minus RT by NF log concentration of Cu is unity 1 by concentration of Cu2, okay. Now, next for anode, similarly we can write anode, okay. Zn2 plus equals standard potential minus RT by NF Ln 1 by concentration of Zn2 plus, okay, like this. Now, what will be the electrode potential of the cell, which will be equal to E right minus E left, okay. So, that is this minus this, E right it is copper, E copper, the electrode potential of copper minus electrode potential of zinc, okay. So, this will be equal to electrode potential of copper minus electrode potential of zinc, like this. Now, So, this will be equal to, how can we write? Cu2 plus Cu, okay, standard potential minus standard potential of zinc, okay. Then next minus RT by NF is common into log 1 by Cu2 plus, okay, minus 1 by Zn2 plus, like this, okay. So, my log 1 by Cu2 plus minus log 1 by Zn2 plus. How can we write this? Cu2 plus Cu, like same, okay. Electrode potential, standard electrode potential, difference of the standard electrode potential of copper and zinc minus RT by NF. How can we write this? Ln zinc, this minus this, so Zn will be numerator by Cu2 plus, okay, like this. Now, this is equal to the standard potential of the cell. So, E of cell is equal to standard potential of the cell minus RT by 2F. So, this difference is the standard potential of the cell. We can write like this, minus RT by NF. N is 2. Number of electrons taking part in reaction 2. Okay. Ln Zn2 plus by Cu2 plus. This will be the equation. Okay. By substituting all these values, we will get the resultant value, that is E of cell will be equal to standard electrode potential of the cell minus, so we are substituting, this is 8.314, this is 298 Kelvin standard state, 2 into 96487, okay. So, this will be equal to the standard electrode potential of the cell minus 0.0591 by 2. Substituting these values, the value will be like this. So, this is ln, we have to convert this into log. So, we are multiplying this by 2.303. Okay. So, this will be log Zn2 plus by Cu2 plus. This will be the Nernst equation of Daniell cell. Okay. So, like this we can calculate the Nernst equation for different cell. This is an example. Okay. Now, let us see what will be the Nernst equation for a general reaction. Consider the reaction AA plus BB gives CC plus DD. This is a reaction. So, E of cell will be equal to standard electrode potential of the cell, okay, minus 0.0591 by N. N is the number of electrons taking part in the reaction. Then log product, okay, product by reactants, okay, like this. This will be the reaction. Now, let us see one example. Consider reaction whose concentration the solutions are given. How can we find the electrode potential of the cell? The cell is, nickel is at the anode, Ni2 plus, okay. Here the concentration given is 0.160 molar, okay. Now, this anode, cathode will be silver, okay, silver like this. This is cathode. Concentration given is 0.002 molar. How can we find the E of cell? That is electrode potential of the cell, and standard electrode potential is also given, that is 1.05 volt. Okay. 0.05. Now, the reaction is E of cell equal E standard, okay, minus. Now, RT by 2F, 2 electrons taking concentration. So, 0.0591 by 2, okay, log concentration of anode, that is nickel is at the anode. So, 0.160 by cathode, it is 0.002 square. Because how can we write the reaction for this? E of cell equal that is nickel plus Ag plus, since it associates to Ni2 plus, so 2 Ag plus, okay, gives Ni2 plus, okay, plus Ag plus. Solid, 2Ag solid, okay. This will be the reaction. So, from this stoichiometric coefficient is 2. So, here the concentration will be square, okay, like this, because depending upon the general equation, this is 2 and this is 1. So, E of cell will be equal to 1.05 minus 0.0591 by 2 log this one. At last we will get the value, substituting all these values we will get 0.14, okay, 0.0591 by 2 log 0.160 by 0.002 whole square. The last value will be 0.14, okay. This is equal to 0.91 unit is volt. So, this will be the reaction, okay. That is 1.05 minus 0.0591 by 2 into 4.6. The value, the log value will be 4.6. So, after substituting all this, we will get the value 0.14. Okay. So, the answer E of cell is equal to 0.91 volt. Okay. This much about Nernst equation. Okay. Next is, how can we calculate equilibrium constant from Nernst equation? Equilibrium constant, which is Kc, can be calculated from Nernst equation. Consider, for that let us take an example, Daniell cell. What will be the reaction for Daniell cell? Zinc and copper Zn2 plus Cu, okay, aqueous, okay. This will be the reaction, Daniell cell, the reaction for Daniell cell. Now, at first what happens, there will be Cu2 plus ions present. Now the reaction starts. Zn gets converted into Zn2 plus. So, Zn2 plus concentration increases. At that time what happens? Cu2 plus concentration goes on decreasing, and at equilibrium there will be no change in the concentration of Zn and Cu. And at this case the voltmeter reading, what will be the voltmeter reading? Your cell will be 0, voltmeter reading will be 0, okay, because the concentration of Zn2 plus and Cu2 plus remains a constant, which will be called as equilibrium constant Kc. Okay, so at equilibrium this will be a constant. Okay, Zn2 plus, concentration of Zn and Cu will be a constant, which is called as equilibrium constant. Now, how can we find Kc? For that, take Nernst equation. E of cell will be equal to E0 standard electrode potential of cell minus 0.0591, okay, by N log concentration of Zn2 plus by Cu2 plus. Okay, this will be the Nernst equation, and we know E of cell is 0 and standard cell, Daniell cell is standard electrode potential is 1.1 volt. It is standard. Okay, so now 0 equal 1.1 minus 0.0591 by n log Kc. Okay, this is Kc. Now next 1.1 equal 0.0591 by 2, number of electrons 2 log Kc. Okay, now Kc will be equal to 1.1 into 2 by 0.0591. This is the equilibrium constant for this Daniell cell. The value is, this is equal to 37.288 log Kc. Log Kc equal 1.1 into 2 by points. So Kc will be equal to antilog of that value. So that will be 2 into 10 raised to 37. Temperature is 298 kelvin. So at standard condition, standard temperature, the value of equilibrium constant for a Daniell cell is found to be 2 into 10 raised to 37. Okay. In general, how can we write this? E standard of cell. This will be 0. This is equal to, instead of this, the 2.303 RT by NF log Kc. This is a general equation. From this, if a standard cell, the standard electrode potential of the cell is known and all these values are known, we can easily find the equilibrium constant. Okay, like this. From the Nernst equation, we can easily find the equilibrium constant of that particular reaction. Okay.